Rutherford's model of an atom. In this module, you will learn about Rutherford's model of an atom. A number of scientists worked on the structure of an atom. One of the first scientists was Sir J.J. Thomson, but his model could not explain the results of several experiments. One of those experiments which could not justify the Thomson model was done by Rutherford. Rutherford's experiment got popular by the name of alpha particle scattering experiment. To understand about his experiment, let us first see what alpha particles are. Alpha particles are emitted by radioactive substances. These are helium ions with double positive charge. Now let us look into the details of the alpha particle scattering experiment. The setup of the experiment consisted of a thick lead box with a hole on one of its walls, a slit, a thin gold foil, and a rotating detector at the end. Inside the lead box, a radioactive substance rich in alpha particles was kept. Now, let us see the experiment. Alpha particles emitted from the radioactive source passed through the hole and entered into the slit to get streamlined. The thin streams of the particles then bombarded the gold foil and got scattered in different directions. Their scattering pattern was shown by the detector. It was expected from the Thomson model that it should show a large number of deflections. But something else was observed actually. The detector showed that most of the alpha particles passed through the gold foil as such without showing any deflection. Only a few of them showed deflection in different directions. A very few of them, essentially 1 in 12,000, rebounded back. Such observations led to significant conclusions. Let us see what those were. As most of the particles passed undeflected, Rutherford concluded that most of the space inside a gold atom was empty. A few particles were deflected from their path by small angles, indicating that there must be a positively charged center, which was repelling alpha particles. As these particles were few in number, this led to the conclusion that a positively charged center occupies a tiny space. The few particles that are rebounded back indicate that all the positive charge of the atom was concentrated in a very small volume in the center. Rutherford named this positive center of the atom as a nucleus. Looking at the proportion of the particles undeflected, deflected, and rebounded, and based upon some calculations, Rutherford concluded that most of the mass of an atom is concentrated in its nucleus. Based on all these conclusions, Rutherford suggested an atomic model, which was known as the nuclear model of atom. According to Rutherford's nuclear model, there is a positively charged center in an atom called nucleus, and all the mass of the atom is due to this nucleus. It also suggested that electrons of the atom revolve around its nucleus. This model was also known as planetary model, as the nucleus of the atom can be compared to a miniature sun, and electrons revolving around the nucleus can be compared to the planets revolving around the sun. But this model did not get much acceptance, as it said that the electron keeps revolving around the nucleus. However, later it was found that any charged body while moving in a circular motion undergoes acceleration. On undergoing acceleration, it should use some energy. So the energy of the electrons should keep decreasing. As a result, the path in which the electron is moving should keep becoming smaller, and thus, finally, it should fall into the nucleus, and hence the atom should collapse. So, the nuclear model could not explain the stability of the atom, and this was its major drawback. Let's recap. Rutherford gave a nuclear model of an atom which was based on his alpha particle scattering experiment. According